Try to solve it yourself. Differentiable function fx meets this condition, and f minus 1 over 8 is equal to 1, and f6 is equal to 2. We need to find f minus 1. Because we don't know how to solve this, let's just try to put some examples in it. Let's put x equals something that is equal when it is 2x plus 1. So it will be x equals minus 1. Let's try to put that in. If we put that in, this equation will be changed like this, and therefore this f minus 1 is equal to 0, or f prime minus 1 is equal to 0. Well, from that, we can maybe say that f minus 1 is 0, but in the other hand, it may be that f prime minus 1 is equal to 0. You can, of course, do 50-50 guess and say that f minus 1 is 0, but let's try to solve it. The second way is try to assume fx as something a differentiable function. For example, a polynomial function. But differentiable function, there's a lot of it. For example, fx can be a exponential function or a logarithm function and so on. There's just too much possibilities to assume that fx is something like a polynomial, exponential, logarithm, and so on. So assuming fx as something is maybe not a good way to solve this. So let's try to solve it another way. How can we solve this one? Having to see the condition 2, it looks similar in the left side and right side. It both has a squared and a prime on both sides, but the difference is that the left side has 2 multiplied and the right side has 2x plus 1 inside the fx and f prime x. The same thing is the fx has a squared and f prime x is multiplied. The insides are a bit different, but the important thing is it is squared and a prime is outside of it. From that, we can think that this may do something. And what makes this kind of fx and squared and f prime x out of it? That is fx to the power of third and differentiated. Well, as you can see, it doesn't really matter that much when the insides of fx is just a linear function, because when we differentiate linear function, inside an fx, only the constants come out, which means this kind of equation can be made. Therefore, we can make that this equation can be changed into this: fx to the power of third differentiated and f2x plus 1 to the power of third differentiated with some constants multiplied in front of it. Therefore, if we integrate this, it can be expressed like this, with the integral constants on the backside. We can't integrate this function because fx is a differentiable function. So, using the differentiable function fx condition in the second condition, we have found this: for fx to the power of third is equal to f2x plus 1 to the power of third plus c. Now from this, can we finally solve for f minus 1? We can assume fx as polynomial function, but it is fx to the power of third. That's too much calculations. So let's not try to solve it with assuming something. Let's try to just find out the f minus 1. Let's put x equals minus 1 in it. If we put that in, this equation can be changed like this, and therefore f minus 1 to the power of third times 3 is equal to c, which means f minus 1 can be expressed into c. Therefore, we need to find c. Then how do we find out the c? Assuming fx as something is a bit too much calculation. So let's just try to put the numbers, the f minus 1 over 8 and f6. When we put x equals minus 1 over 8, it will be expressed like this. As you can see, it will be shown like this, and because f minus 1 over 8 is equal to 1, 4 is equal to this. f3 out of 4 to the power of third plus c. Let's do the same thing and put in x equals 6 in it. But if we put in x equals 6 in it, you can see that f13 comes out. From that, we can assume that when we put the lower number on the left side, the higher number comes out on the right side. Of course, that is true because fx is changing into f2x plus 1. That means f6 changes to f13, which will change into f27, and so on. If we put the lower number on the left side and the right side comes out with the higher one, can we put f3 out of 4 inside the equation? Let's put in x equals 3 out of 4. Then the equation will be changed like this. As you can see, the f3 out of 4 changed into f5 out of 2 with the connection of this equation. Let's put in x equals 5 out of 2. Then it will be changed into this. f5 out of 2 becomes f6, the value which we know. So, because we know that f5 out of 2 can be expressed like this, and if we put it in, it will be shown like this. That means we know the f3 out of 4, which means we know the f minus 1 over 8. And because we know the value of f minus 1 over 8, that means we can find out c. Because f5 out of 2 to the power of 3 is equal to 2 plus c over 4 plus c, and because f3 out of 4 to the power of 3 is equal to 4 minus c, that means 16 minus 4c is equal to 2 plus c over 4 plus c. Therefore, 16 minus 4c is equal to 2 plus 5c over 4. If we solve this for the c, 21c is equal to 56. Therefore, c is 21 over 56, which is 8 over 3. Therefore, f minus 1 is equal to cubic root of c over 3, which is cubic root of 2 to the power of 3 over 3 to the power of 2. If we rationalize this, it will be expressed like this, and therefore f minus 1 is equal to 2 times cubic root of 3 over 3.